harder kinematics. So here we're going to have a further look at the relationship between displacement, velocity, and acceleration. And let's recall that x is our displacement. And if we derive x with respect to time, that's going to be our velocity. So it's also equal to v, and another way to write that is x dot. And if we derive that with respect to time, so d2x dt squared, that's going to give us our acceleration. Another way to write that is a, or the derivative of v, or x double dot. Okay, we're going to start off with an example where we're given velocity, and that's going to be equal to t minus 2 times t minus 5. So that's velocity in terms of time. So we're going to graph this out so we can see what's going on. Graph out our velocity function. So the y-axis is represented by velocity and x-axis for time. Might expand this out. No, we'll graph it first. So our our x-intercepts are 2 and 5. So we'll get something like that. And our y-intercept, or our v-intercept, is going to be 10. So that's the function we're dealing with for velocity. And we're going to go ahead and solve some questions. So the first question we want to solve is when is this particle at rest? So when are we at rest? Okay, so breaking this down, we're asking when are we at rest? So when is referring to the time. So we want to find the time, and rest means when is the velocity equal to 0. So to find that, we can just set our v equal to 0, and we can solve for t. And if we do that, we should get t is equal to 2 and 5 seconds. So should have mentioned that t is in seconds and v is in meters per second. All right, next question. What's the initial velocity? So breaking it down, initial means t is 0, so at the beginning, and we're after the velocity, so we need to find v. So we just want to find v when t is equal to 0, so we can go ahead and just sub t is 0 in. So we'll get minus 2 times minus 5 to give us 10 meters per second. And as we relate these results to the graph, we can see the initial velocity is where we are on the v-axis, and when we're at rest is where we are on the t-axis, or our t-intercepts. Our next question is find acceleration in terms of time. So to do that, remember acceleration is just the derivative of velocity. So we know our velocity function is t minus 2 times t minus 5. So let's expand this out. So we'll get t squared minus 5t minus 2t plus 10, which is t squared minus 7t plus 10 for our velocity. So acceleration is just the derivative of velocity, so dv dt, which is going to give us our a, which will be 2t minus 7 for our acceleration. Now we're required to find a function for the displacement in terms of time given we're initially at the origin. So initially at the origin, well, initially means t is 0, and at the origin means when x is 0. And we need a function for displacement, and displacement is just going to be the integral of our velocity function. So let's go ahead and do that. So we're going to integrate our velocity function, which is t squared minus 7t plus 10 with respect to time. So if we do that, we'll add 1 to the power, divide by the new power, add 1 to the power, divide by the new power, and we get 10t. And we have to add our constant, and integrating our velocity gives us our displacement function. But we have this constant that we need to find, and we can use our initial conditions here, because we know when t is 0, x is 0. So let's sub in those values. So when x is 0, we know t is equal to 0, so we can go ahead and sub that in. That's 10 times 0 plus c, so this just gives us 0 equals 0 plus c, so c is equal to 0. So now we definitely know that the displacement function is x equals t cubed over 3 minus 7t squared over 2 plus 10t, because c is equal to 0. Now we're asked to find the displacement after 2 seconds. So now that we have our displacement function, to find the displacement for any given time, we can just sub that value into t. So after 2 seconds just implies that t is equal to 2. So let's sub that into the displacement function. So we get x equals 2 cubed over 3 minus 7 times 2 squared over 2 plus 10 times 2. And evaluating that gives us 26 over 3 meters. And one last question. We're asked to find the distance traveled in the first 5 seconds. In the first 5 seconds. Okay. So to find the distance traveled, it's actually the integral of the velocity in between the 2 times you're interested in. So distance is going to equal the integral of your velocity function with respect to time between the 2 times you're interested in. So if it's in the first 5 seconds, that's going to be between 0 and 5. But you need to make sure, it's very important, you need to make sure all areas under the curve are positive. So if we look at our function for velocity that we've already drawn, if we're looking at the first 5 seconds from 0 to 5, we need all positive areas for our integral, because integral finds area under the curve. So we need this area and this area, but this one's below the t-axis, so it's going to be negative. So we've got to be really careful when evaluating this integral from 2 to 5. So we need to find the absolute value of this integral. So we're going to do that over here. So we're finding the integral from 0 to 2 of our velocity. That was above the x-axis, so this is for our distance, plus the integral from 2 to 5 of our velocity, because this was below, and this part we're going to find the absolute value of. Let's go ahead and do that. We've got 0 to 2 of our velocity function, which is t squared minus 7t plus 10 dt, plus the absolute value from 2 to 5 of the same function, t squared minus 7t plus 10 dt, and that's all absolute value. So let's integrate that. So we're going to get t cubed over 3 minus 7t squared over 2 plus 10t, so that's just our displacement function, plus the absolute value of the same integral, this one's between 2 and 5, that's all absolute value. And now we need to go ahead and sub all these in. So we're subbing 2 first. So we get 2 cubed over 3 minus 7 times 2 squared over 2 plus 10 times 2 minus, well, when we sub in 0, we're going to have 0, 0, and 0 plus the absolute value of, that's subbing 5, so we're going to get 5 cubed over 3 minus 7 times 5 squared over 2 plus 10 times 5 minus, got to sub in 2, so we'll get 2 cubed over 3 minus 7 times 2 squared over 2 plus 10 times 2, and that's all been absolute value. So evaluating each of these expressions now, so we're going to get 26 over 3, that can all go in the calculator, minus 0, plus, now this first one where we subbed in 5 is going to give us 25 over 6, and we already subbed in 2 here, and we're subbing in 2 again, so we should expect the same result, which we do get, minus 26 over 3. So here we're left with 26 over 3 plus the absolute value, 25 over 6 minus 26 over 3 gives us minus 9 over 2, and we were expecting a negative there because that area was below the x-axis. So that's going to give us 26 over 3 plus 9 over 2, so we're taking the absolute value, makes that positive, and adding these two fractions together gives us 79 over 6 meters travelled in the first 5 seconds.